Today we're going to look at taking our theorems that we know, our list of reasons, and forming some proofs from them, writing proofs. So just to talk a little bit about what a proof is, in geometry we follow a deductive thought process to prove things. And that's what makes geometry a little bit different, although at this point you're used to justifying statements in algebra as well. So if we look at what we did with the exterior angle theorem, when you needed to figure out the measure of A, and we use the fact that an exterior angle equals the sum of the measures of the interior opposite angles, then you could calculate that A is going to be 36 degrees. So that's a numerical example. But what we're going to do is we're going to replace our numbers with letters, which are down here, X, Y, and Z, because what we can do is prove the general case. By proving things with just letters and variables, that makes the statement true for any value that we want to put in. So that's called proving the general case. And we're going to do that based on, we're going to consider this one known fact. And our knowledge, the known fact, is that the angles of a triangle add to 180. That's one of the things that we know. The other thing we know is the fact that linear pairs add to 180 as well. So we're going to use those two things, and we're going to write a proof for the exterior angle theorem. So for this proof, we actually have our steps listed. So I'm going to walk you through the steps and the reasons for each one. The first step was to actually make sure every angle has a label. So we labeled angle W in there. You can label them anything you want, and there's not really a reason that you need to label them. So you just say you label W. And then our first statement is the measure of angle X plus the measure of angle Y plus the measure of angle W is equal to 180. So that reason, X plus Y plus W, if you think about it, that's going to be the sum of the angles in a triangle. The sum, I'm not writing very well today, let me fix that. The sum of the angles in a triangle add to 180. Sum of the angles in a triangle add to 180. Okay? And then we have the fact that the measure of angle W plus the measure of angle Z is equal to 180. That's because angle W and angle Z are linear pairs. So linear pairs are supplementary, or add to 180, either way. Supplementary. Okay? So there's that reason. Then what I have is this side of the equation is here, and the W and the Z is on the other side. Because what we're going to do, we use substitution to get there. Since both of those statements are equal to 180, I can replace the 180 with this expression. So that's just the substitution property. And then finally, what happens is you end up with the measure of angle W on both sides, and they subtract away. So that's subtraction, and you've finished up. So we've used these reasons before. We've just, up until now, we've done numerical examples. Each step in the proof was justified by a previously known or demonstrated fact. So we had the sum of the angles in a triangle adds to 180. Linear pairs are supplementary. We have the substitution property, and then we have the subtraction property. I'm going to put property in here. That gets us to our final answer. So all of that, that process using known facts to reach a conclusion, that's called deductive reasoning. Alright, so the first example we're going to look at, we're going to prove that vertical angles are congruent. Now that is a statement that we've already kind of talked about, but today we're going to prove it. And we're going to start with the assumption that linear pairs or angles on a line add to 180. So we can look at this. When you do a proof, it's good to kind of look back and make a plan before you just jump into things. Think about the things you know. And sometimes if you think about what you know and you write it down, you can find a path to get from the beginning to the end. So if you look at this and you think about what do you know about angle W and angle X, and angle Y and angle Z. And if you think about it, W and X are angles on a line, and Y and Z are angles on a line. So they both add to 180. And W and Z are angles on a line. So we can start to look at this and write down what we know. We can say the measure of angle W plus the measure of angle X is equal to 180. And we can say the measure of angle W plus the measure of angle Z is equal to 180. And that's because angles on a line add to 180. Well, then if you look, we can use substitution. Since they're both equal to 180, then they're equal to each other. The measure of angle W plus the measure of angle X is equal to the measure of angle W plus the measure of angle Z. And that's the substitution property. Substitution. And then by subtraction, if I subtract away the measure of angle W, I get the measure of angle X is equal to the measure of angle Z. And that's subtraction. Okay, and that proves that vertical angles are congruent because we proved the general case. We don't use numbers. We end up with an expression just with variables. So now we're going to use that last theorem about vertical angles being congruent, and we can use that with the sum of the angles in a triangle to prove the next statement. The measure of angle W plus the measure of angle X plus the measure of angle Z adds to 180. So if you look at the diagram, W plus X plus Z adds to 180. So again, think about what you know. Make a plan first. What do you know about X, Y, and Z? Think about that. And hopefully, by looking at the diagram, you've come up with the fact that the angles X and Y and Z have to add to 180. So the measure of angle X plus the measure of angle Y plus the measure of angle Z add to 180 degrees. And that's the sum of the angles in a triangle. I'm going to start abbreviating. Angles in a triangle add to 180. Okay? Now we also know the vertical angles are equal in measure because we just proved that. So we can say the measure of angle W plus the measure of angle Y, oh, not plus, hold on. The measure of angle W is equal to the measure of angle Y because vertical angles are equal. Vertical angles, or we could say vertical angles are congruent. Either way, I'll say equal. Equal in measure. So if you look at those two statements, since W is equal to Y, I can replace the Y up here with the W. And then I get my final statement. The measure of angle W plus the measure of angle X plus the measure of angle Z is equal to 180. And that's just the substitution property. And that's it. So these proofs really aren't that big. They're only a few steps. The substitution property, and that's all you need. And then finally, the last one, we want to prove that the measure of angle W is equal to the measure of angle Y plus the measure of angle Z. So this one we're going to use the exterior angle theorem. So we know that W is equal to X plus Z. We also know that X and Y are going to be equal to each other. So you take a minute and think about it. This is going to be a job for you, and then we can go over it in class. You're going to use the exterior angle theorem, And you're going to use the fact that vertical angles are equal in measure. And then possibly some substitution or something. See if you can come up with the steps to show that the measure of angle W is equal to the measure of angle Y plus the measure of angle Z. And we will practice more of these in class.